So if you're a Cloud.gov user, you probably know that the open source project called Cloud Foundry is at the heart of Cloud.gov. However, it takes a lot to actually build a platform around Cloud Foundry, as well as to provide the services to those end users. And that's really what we're going to talk about in this section. Now, you also probably know, if you're a Cloud.gov user, that most of what we do actually runs in AWS and Amazon Web Services in their GovCloud offering. GovCloud is different than Amazon Commercial. Amazon Commercial Cloud has more services and different features. GovCloud has FedRAMP approved services. We run in a single GovCloud region in US West right now. There are only 2 regions in GovCloud, US West and US East, but we run in the US West region. And most of what you're going to see on this board is actually deployed to AWS GovCloud in US West 1, but not everything. We actually use commercial for some of these elements as well too. So before we can even deploy Cloud Foundry inside of GovCloud, we need to set up a bunch of infrastructure. We use a technology called Terraform to do that. Terraform is an infrastructure as a code solution, so it allows us to define what our infrastructure needs to look like. And there's a couple key components that I'll highlight here. And again, I'm not going to go into too much detail in this section, but we want to deploy our Cloud Foundry instance in GovCloud inside of a VPC, or a virtual private cloud. This gives us essentially a safe space where we can do things like apply security groups, which control ingress and egress into that particular virtual private cloud. We can do things like define the subnets or networks that are available and who can access those networks as well. Again, another layer of security. And it allows us to provide other policies, define things like IAM users, etc. And we do all of that through Terraform. Now, the Cloud Foundry instance itself is also going to need a few things provisioned ahead of time. One of those things is some databases where it can store its information. And for that, we use Amazon's RDS, or Relational Database Service. And we provision those also through Terraform. The Cloud Foundry instance is also going to need a place to store objects, or a blob store. And we use, again, Amazon's S3 as the object store for Cloud Foundry, again, provisioned by Terraform. We're also going to want to be able to get traffic into this Cloud Foundry instance and ultimately get traffic so that your end users can access your applications. And there's 2 components that come into that. One is we need DNS. And for that, we use Amazon's Route 53 service, which is their DNS service. And this is actually running in AWS Commercial and not in GovCloud. The other thing we will end up needing is load balancers to load balance traffic coming into our Cloud Foundry instance for different reasons. And for that, we use Amazon's ALBs, or application load balancers. You may have heard of ELBs before, or elastic load balancers. This is the new version for Amazon. And so these provide load balancing services for our different app domains, for your specific agency domains if you're bringing a custom domain, and a few other things that we'll get into throughout the various videos here. So once we have all of these things provisioned before our Cloud Foundry instance, again, using Terraform, now we can actually deploy a Cloud Foundry instance. And for that, we use a different automation tool called Bosh. And Bosh is a little bit different from Terraform in that Bosh is essentially deploying clusters of VMs. And so what Cloud Foundry really is sets of clusters of VMs. And what that really means is that when we deploy Cloud Foundry, it is essentially running on Amazon's EC2, or Elastic Compute instances. And it is essentially a cluster of different VMs with different software on them. Now, the reason we don't use Terraform to deploy that is because Bosh is a full lifecycle management automation tool. So it allows us to do things like update Cloud Foundry. As new releases from the open source project come out, we can deploy them as we do multiple times a week to provide patches and new features, all with 0 downtime. So there's some significant differences between what Bosh does and Terraform does, but we use Bosch to actually deploy anything that is running on Amazon's EC2 or Elastic Compute instances. Now, once we do that, we obviously have a running Cloud Foundry instance finally. That Cloud Foundry instance is using RDS and S3 for its storage. It is essentially, like I said, a cluster of virtual machines. And then when traffic is coming in, it's getting resolved through our DNS and Route 53. It's getting load balanced through our application load balancers, and then it's finally coming into that particular Cloud Foundry instance. So that gets us a nice running Cloud Foundry. Now, as operators, we need to have some visibility into this particular Cloud Foundry instance. And so we also deploy a fairly significant set of tools, typically, again, through either Bosch or Terraform, that give us visibility. And I'm not going to get into too much detail here, but I will highlight just a few. And so we deploy Elasticsearch, Logstash, and Kibana, or you may hear it called the Elk Stack. And this is basically deployed to give us visibility into platform logs. So we gather and aggregate logs from the entire running platform, and we have visibility into the Elk Stack. Now this is different if you're a Cloud Foundry, or excuse me, a Cloud.gov user, and you're going to logs.fr.cloud.gov. This is actually a different instance. We'll talk about that one here in a second. In addition to the Elk Stack, we use another open source technology called Prometheus. Prometheus is providing alerts for us, so it lets us set boundaries on metrics and allows us to get alerted when things are kind of getting outside of the norm. We use another technology called Grafana, and that provides us visibility into running metrics over time. So we can see how the different components within the entire platform are actually behaving, and we can see things like CPU utilization and memory utilization, requests per second, etc., all through Grafana. And that again is also Bosch deployed. So everything kind of over here on this side of the picture is really an operator concern. And actually everything in the middle is really an operator concern, except for the experience that Cloud Foundry is bringing you, which is essentially an experience of bring your apps, we'll run them. You don't need to worry about all of this other complexity. But in addition to this, the basic open source Cloud Foundry and the compliance and security and monitoring that we apply to it, we also want to provide additional services to you, our customers. And so we add additional services to this Cloud Foundry instance. So one of those things I've already mentioned before is the Elk Stack. And so if you go to logs.fr.cloud.gov, what you as an end user of Cloud.gov will see is all of your application logs. So this is a place that you can go using Elasticsearch, Logstash, and Kibana to actually see all of the logs for all of your applications inside of your organizations and spaces, all of the applications that you as a user of the Cloud Foundry platform have access to. And we manage that for you, so you don't need to actually do anything for that. You can also use your own log drains, but we want to make this easy for you as well. So then we also Bosch deploy a large number of brokered services. And we're going to talk more about what are brokered services and what are service brokers in particular in a future video here coming up. But each of these components is essentially a piece of software that provides automation around the lifecycle management and credential management of the different services that we bring to you, the end user of Cloud.gov, in a self-service fashion. So you can go into Cloud.gov and you can provision instances of Amazon's RDS according to bounds that we've set up. So if you need a MySQL database or a Postgres database, you would use Amazon's RDS to do so. And we've predefined plans that allow you to pick and choose the size of the cluster that you're creating, and the flavor of the cluster, whether it's MySQL or Postgres, et cetera, all using a standardized API. And like I said, we'll talk more about that as we go through the next sections here. So we also manage service brokers for Elasticsearch, Redis, and Amazon's S3. if you've used the previous versions of Elasticsearch and Redis, those actually were not using Amazon's actual Elasticsearch and Redis offerings. The new versions are, and they're far more stable, they're far more robust than what was there before, but those services didn't exist when the other offerings were put in place. But again, through service brokers that we manage through Bosch, you have the ability to basically go in and say CF create service and provision an entire Elasticsearch cluster. You don't need to know anything about how to provision that cluster, how to manage credentials on that cluster. All of that is encapsulated again through these brokered services. And then the last two services that I'll highlight here before moving on are our custom domain service and our CDN service. And both of these have actually been merged into a new offering, a new service broker. But again, that is custom code and custom automation that we as Cloud.gov operators write and maintain. And that allows you to basically bring your domain to Cloud.gov. So you might have myagency.gov and you want to use Cloud.gov to host that. We make that trivially easy for you to bring that custom domain to us. Or maybe myagency.gov has a massive worldwide presence and you need a global cache or a content delivery network. We make that very, very easy too. And that content delivery network actually uses Amazon's CloudFront as its CDN service. And Amazon CloudFront is the other service on this board that's actually running in AWS commercial and not running in GovCloud on US West 1. Now, to round out the picture of what else these two services in particular use, there is another third party that is not Amazon that we rely on to allow you to bring your domains, whether it's a custom domain or a CDN, to Cloud.gov easily. And that service is called Let's Encrypt. And so Let's Encrypt is a third-party provider of certificates. And one of the most powerful things about using either the custom domain service or the CDN service is that the service broker, again, the automation that we've written, will go out to Let's Encrypt. It will fetch a certificate, a valid certificate for your custom domain at myagency.gov, as an example, and it will configure it correctly in the platform so that you don't need to do that. And the other beautiful part about that is it's looking at the validity of your certificate. And so Let's Encrypt certificates are valid for 90 days. Before that 90 days expiration, this service broker, again, the automation that we control, will go out to Let's Encrypt and it will automatically renew that certificate for you, and it'll update that certificate in the appropriate places in this infrastructure. So that's a pretty significant set of features. But I want to go back to what I said earlier, right? One of the focuses of Cloud.gov is to focus on our users, for you to be able to just bring your applications to a platform, not really need to worry too much about a lot of the different compliance concerns that go into the backing of all of these services and the FedRAMP applicability of all of these services, but also not worry about any of this underlying infrastructure, right? And what we're going to look at in the next section is what actually happens when you deploy an application to Cloud.gov or to Cloud Foundry in this case. But the purpose of this section is to give you a little bit of understanding of all of the different parts and pieces that go into making that experience so simple and so easy. We want to take that off your plate so again, you can focus on your apps.